everyone. So one more thing we have to add to our notes from yesterday is this table down at the end. And this is a really important example for a couple of reasons. First and foremost, there is a table that looks very similar to this on your chapter test. So when we reach test time, you may want to reference this video and check out these examples again. And when we get to that test and the test review and all of that, I hear from students a lot that they don't understand the table. I'll have students say, I understand everything in this chapter, but I don't understand the table. I want you to realize that the table is not a separate concept. The table is just pulling together all of these things that we've already talked about. Okay, we've talked about slope, we've talked about intercepts, we've talked about parallel and perpendicular. It's just putting it all in one place. And I get that that is difficult. Okay, it's a little overwhelming, but I don't want you to think of this as like a new procedure you have to learn, okay? So let's work through these together. This first equation here is in slope-intercept form, mx plus b, which means that my slope and my y-intercept should be like handed to me on a silver platter, right? My slope is 1/2, and my y-intercept is -5. Those are just sitting right there for me, okay? In addition to that, my parallel line slope is really easy because we know that the slope of a parallel line has to be the same as the original slope. Okay? So really these two columns are going to match all the way down. So if this is a 1/2, then this is a 1/2. The perpendicular slope is the opposite reciprocal of this one. Really, it's opposite reciprocal of the original, but since they're the same, it doesn't matter. Okay? So opposite reciprocal of 1/2 would be -2. So now let's talk about that x-intercept question, because this is going to require a little bit of work. And I think this one throws people off a little bit because all of these other ones were so easy. They could just look at the equation and find it. This one requires some work, okay? To find an x-intercept, we have to plug in 0 for y. Okay, and so I'm going to go down here and do this. I'm going to rewrite this equation, but with a 0 in place of y. And then I have to solve that for x. So the first thing I would do is add 5 to either side. I end up with 5 equals 1/2 x. Okay, and then to solve that thing from there, I would come in and multiply by 2. Really, I'm multiplying by 2 over 1, but we know that that's just 2. Okay, and the 1/2 and 2 over 1 are going to cancel. Here I'm going to be left with 10 equals x, and so then my x-intercept is 10. Okay? Okay, so let's look at this next one. This one is in standard form, which means these aren't quite as easy to find, but they're still not that hard. Okay? I did mention a trick up above, so hopefully you've already filled in that section of your notes, that when things are in standard form, so we don't just have an m sitting there, and I should have left myself some space there, we can also use -a over b for slope. How do I want to do this? I'll just squeeze in an or. Okay, so when it's in standard form, you can find the slope very easily by doing -a over b. So in this case, that's going to look like this. -2, because I'm doing the negative of the a value, which is 2, over the b value, which is already negative, so I get -2 over -3, and then when I simplify that thing down, it just becomes 2/3. Okay? Now, for my x and y intercept, we said back here to plug in 0 for y. Remember that for your y-intercept, really, we could plug in 0 for x. We just didn't have to the last time because this was an easy one to get the y-intercept from. Okay, so when I plug in a 0 for x, really what I'm doing is canceling out the x, and I'm left with -3y equals 15. So I don't think I have to take the time to like do all of this work, but I am going to solve by dividing by -3. So 15 divided by -3 is -5. Okay. To find the y-intercept, to find the x-intercept, I'm making the y a 0, and I don't have a good way to cover that up. Let's see. So I end up with this. Nope, that doesn't work. There, I'm covering up the 3y, so I end up with 2x equals 15. Okay, divide that by 2 and we get 7.5 for my x-intercept. My parallel line slope is going to be exactly the same as it was back here, so I'm going to go with 2/3. And then my perpendicular slope is opposite reciprocal, so that would be negative 3/2. Okay, that next one, we have to come up with our own equation. So let's see what information they gave us. I have that the parallel line has a slope of 6. That means that I know my regular slope, right? If my parallel line is 6, then this slope must be 6 as well. And then if I have this and this, I've got my m and my b to write an equation in slope-intercept form. So that's what I would do. I would just write this straight in mx plus b form. Now, some of you may figure out a way to write this in standard form correctly, and I'm okay with that if you know how to do it. But I think this is the easier way to go, so that's what I'm going to do. Okay? So remember, for my x-intercept here, I'm going to need to do some work, right? And so I'm going to come down here, and I'm going to plug in a 0 for y. So 0 equals 6x plus 4. Subtract the 4, I get negative 4 equals 6x. And then divide, and I'm going to end up with, well, really I get negative 4/6 for x, but then I'm going to reduce that to negative 2/3 for my x value. Okay, so my x-intercept here would be at negative 2/3. Okay, and then for my perpendicular line, I'm doing opposite reciprocal of this. So opposite turns it to a negative 6. The reciprocal makes it a 1/6. So I'm going to have negative 1/6. Okay, this next one's kind of an oddball. Okay, and so I'm going to put, gosh, I'm running out of symbols here. But this one's kind of strange. This one works a little different than all the others. As soon as I see this, I want you to think, hey, I know what this is. This is a vertical line, right? X equals a number is just a vertical line. So the slope for a vertical line is undefined. You should know that one off the top of your head, that that's undefined. If it's vertical, it has no y-intercept, and that's usually the easiest way to do it. You could write none. You want to make sure you're not writing 0, though, because 0 is an actual y-intercept. Okay? X-intercept is just the negative 3. My parallel slope would also be undefined. For my perpendicular slope, the opposite reciprocal of undefined, well, think about it. What would be perpendicular to this vertical line would be a horizontal line. That has a slope of 0. So these two things are opposites from each other. And so when you're dealing with perpendicular lines, undefined becomes 0. Or if my original slope was 0, the perpendicular would be undefined. Okay? All right, and one more. This one, again, they give me a y-intercept here, which is nice. They don't give me this slope or this slope, but they do give me the perpendicular slope. I can work backwards from that, right? So if I have this slope, I know that this is going to be the opposite reciprocal of that. So I'm starting here, okay? And I'm going to make that a negative 1/5, okay, because that's opposite reciprocal from 5. I can go ahead and fill this one in right now. Negative 1/5. I have my m and my b, so I'm going to just go straight to slope-intercept form. Okay, and then all I need now is my x-intercept, which again, we'll just do a big dot. Okay, I'm going to do that work right here. And so I'm putting 0 in for y. I'm going to add the 2 to the other side. And then to get rid of a negative 1/5, I'm going to multiply by the reciprocal, which would be negative 5 and negative 5. That negative 5 is going to cancel with the negative 1/5, because remember, that's really negative 5/1, okay? And so then I end up with negative 10 for my x value. And so my x-intercept here is negative 10. Ooh, that bothers me that I did that one in green and the other one's in pink. Oh well. So I really think these ones are the ones that throw people the most often because they kind of get caught off guard by having to do this extra step down here. Okay, there's really not a better way to do it. I mean, some of you may be able to do some of this in your head, but this is the process you have to go through to answer those questions. However, when equations are written in this form, you can get away with just saying, oh, I'm plugging in a zero, meaning I'm canceling it out, and then I have this really simple, easy equation to solve. But when you have to put the zero over here, there's a couple more steps necessary. Okay? All right, hopefully that helps some with those things at the end of the table. I think you now have an assignment where I'm going to ask you a couple of questions about those. So go ahead and give those a try, and we'll go over anything you need to when I see you in class again.